All right, so we talked about this birthday problem in class, and I'd said that there was a video that had the solution, like how to theoretically calculate it. Well, there wasn't. Usually I don't cover it in class, but I figured I'd cover it here. Just know that this is not something you guys need to know how to do in class, okay? Or for the test. It's too hard. So let's say we have 30 kids in class, and we want to find the probability that at least 2 of them match up their birthday. So this is a probability that at least we get at least 1 match in 30 kids. Well, this is an at least 1 thing, so let's calculate the complement. This is 1 minus the probability that we get no match. So we just got to calculate the probability that you don't get any matching birthdays. All right, so the first kid walks into the classroom, the first of 30, and obviously his birthday is not going to match up with anybody's. So there's not going to be any probability associated with that, or basically there's a 100% chance that he doesn't match up with anybody's birthday. So I'm going to just write this as 365 out of 365. You guys might say, well, why would you do that? Well, basically, when that person walks in the classroom, we're guaranteed not to get a match. So there's a 100% chance that the first kid doesn't match. Times the second kid comes in. Now there's 1 kid already in the room, so the probability that new kid's birthday is the same as the other kid's is 1 out of 365. That's a probability you do get a match. Well, the probability you don't get a match is 364 out of 365. Because there are 364 days that kid's birthday can be so that he doesn't match up with the first kid. Times, third kid walks in, 363 out of 365. Because now there's 2 birthdays, there's 2 days of the year that are taken up, and if that kid has either of those 2 days, he'll match up. So what's the probability he doesn't match? 363 out of 365 times, so hopefully you guys can kind of see the pattern here. Well, the last one. They all have 3. So, by the way, there are going to be 30 of these little factors. This is the first kid, second kid. This is the 30th kid. So there are 30 factors. Last one's going to be 365. So what's the last number here going to be? Well, it's going to be 365 minus 30, or 335. Well, that's actually going to be the next number. So this is going to be to 336, I believe. So it gets a little confusing because, you got to make sure that that's it. That is the probability. So it's really not that complex to calculate. It's just really cumbersome to type in all of these into the calculator. In fact, I'm going to type this into the calculator, but I'm going to kind of simplify it. So basically, the bottom is going to be 365 to the 30th power. But how am I going to get the 365 times 364 times blah, 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 all the way down to 336? I don't want to multiply those all out and type all 30 numbers. Remember, 365 factorial is going to go from 365 all the way down to 1. So basically what I want to do is I want to cancel out all the ones that are from 335 down to 1. So if I take 365 divided by 335, which is basically the 365 minus the 30 factorial, that's going to be the 335 factorial, which will cancel out all the ones that I don't want and just leave the top 30 that I do want. So this is going to be 365 factorial over 365 minus 30 factorial. What I kind of like about this is it allows me to kind of generalize it to any number of kids I want. Want to do 30 kids? Do that. Want to do 20 kids? That's 365 factorial over 365 minus 20, let's say n kids, minus n factorial, all over 365 to the nth power. So this will give me any number that I want. So let me verify it with 1 value. So 1 minus 365 factorial over 365 minus 30 factorial over 365 to the 30th power. If I hit enter, it gives me some crazy number. Hit control enter, 70.6%. So I found an applet that kind of, there's a ton of calculators out there, but if you put in 30, it calculated the probability as 70.6%. So that kind of matched up with that page. It also matched up with this right here. If you project up, I think in class I had a hard time getting it projected up like that, but looks like it's actually below 70, but whatever, it's 70. I calculated it. Okay. If we wanted to, we could make a function. We could take this function and we'll put in n for the number of days. So we'll call that the number of kids in the class. So we'll go n. So this is a function of n. Let's store that into the birthday of n. In fact, let's type in a times 1.0. That'll give me decimal approximations. So if I go b of 30, it gives me the probability that 30 kids' birthday will match one. You'll get at least one matchup in 30 kids. If I said b of, I think in our class we had maybe 17 or 18, I don't remember, 18. See, that drops it down to 34%, 35%. If you had a class of 100 kids, that would actually be, well, you can't even, looks like it's 100%. It's not. It's 0.9999999. So if you got 100 kids in a class, there's like a 99.999999% chance that somebody's birthdays are going to match up. That seems surprising to me and perhaps to you as well. But you can play around with it, put in different numbers. What if we have 5 kids? That's going to be pretty small. Only 2%. What if we have 2 kids? Well, 1 kid, I think it's probably going to get some kind of error on 0, whatever, I guess. 2 kids. I think 2 kids should be 1 divided by 365. Right? Yeah, see, the probability that 2 kids' birthdays match, well, there's going to be a 1 in 365 chance of that. 50 kids, chances are going to be really pretty high. 97%. 50 kids in the classroom, 97% chance you're going to match. If you don't believe it, I don't know what to tell you. You should. That's true. We could even make a table and produce this graph if we wanted to. My video's at 8 minutes. It's optional. You don't have to watch it. I'm gonna do it. I'm gonna make a table. I'm gonna put in some values like 1, 2. Let's go up to about 50 or so. Up to 50. Call this number of kids, number. Then this is going to be the probability. We'll call it prob. To calculate it, we just take our function b of our column A, or b of the number of kids. And we make a scatter plot of that. Number of kids versus the probability. And there we go. We see that. By the way, it looks like a logistic curve. To be honest, I think it probably is a logistic curve, but I don't know if it is, or I don't know why it is, or any of that. But I'm willing to bet that there's probably some math out there for it. So, moral of the story: be careful about your intuition. It's not always correct.